All right, so today we're going to go over histograms and distributions. So a histogram is a bar graph that is used to display the frequency of data divided into equal intervals. The bars must be of equal width and should touch but not overlap. The height of the bars indicate the frequency of data values within each interval. And then the frequency, right? The frequency of a data value is the number of times it occurs. Our frequency table shows the frequency of each data value. If the data is divided into intervals, the data table shows the frequency of each interval. All right. So just wanted to give you the formal definitions of everything, but we'll jump right into it and do an example. So for this example, we've got the ages of people visiting a water park during a certain time period are given below. Use the data to make a frequency table with intervals, then make a histogram. So here's our data. We've got, these are the ages of people that are visiting. So 5, 12, 22, 15, 17, 13, 25, 34, 7, 9, 12, 32, and 12. All right. So our first step, and let's see. So our first step is going to be find the difference between the greatest and least values, right? Our max and our min. We can put that in the calculator. Remember when we did our 5-number summary and find the max min using our graphing calculator. In this case, we have our smallest value is 5, our greatest is 34. So 34 minus 5, we get 29. And we're doing this because what we want to do is we want to be able to break it up into intervals, right? We don't want to just have one bar for each number, because if we had one bar for each number, I did the graph already. Let me just show you what that would look like. If we did the one bar for each number, or one, frequency of 1, this really doesn't help us out, right? This, we can look at it, we can get the range from it. But other than that, it doesn't really give us too much information about the data. So this is where we want to break it up into intervals. So just as a guideline, 3 would be too few, 10 could be too many depending on the data. And in this case, 6 is going to be good. So what they did was they said, okay, let's do a width of the interval of 10. So if we take 29, our range, and divide it by 10, it tells us we're going to have 3 columns or 3 bars. If we said the interval would be 3, so it would go like 5, 6, 7, all those values would be listed in one bar. So basically, this is for finding the intervals. On the regions, for the most part, you would be given the interval, but again, this is a way of finding it. So basically, you take the range and you divide it by what you want to do the width of your interval to be. Okay. So, and it says try different widths for your intervals to determine the number of bars in the histogram. So on this one, 6 is a good number, so we're going to go with 6. So we're going to have a width of 5. All right. So we create our frequency table. So we take all our data here and we just put it in. So 5 through 9, we have 5 numbers like that. So, this one right here is a 5 through 9, 7, and 9, right? So we've got 3 like that. So it just goes through and just doing that to figure out what you have. So we put it all in a frequency table. So that's the amount that we have, or the number of people that fell between the ages of 5 to 9. We had 4 people that fell between the ages of 10 to 14, 4 people between the ages of 15 to 19. And again, we're just doing that with the data that we have up here. And then step 4, use the frequency table to create the histogram. All right. So when we do that, basically we have our intervals down here, right? 5 to 9, we had a total number of 3 people that had ages between 5 and 9. 10 and 4, or 10 and 14, that should be. We had a total number of 4 for them. So we can set up our histogram based off of our frequency table, right? It has a height of 3. This one has a height of 4. This bar has a height of 4. 20 to 24 has a height of 1, right? 25 to 29 has a height of 1. And then 30 to 34 has a height of 2. Okay. So some of the questions that you could be asked was how many people are represented in the histogram. So looking at this, we go, okay, we've got I've got the height of each column will tell me how many are in each category. So 3 plus 4, right? The second bar is a height of 4. The next one is a height of 4. Oh, the next one's a height of 1. The next one's also a height of 1. The last is a height of 2. So we want to see what we get. We've got a total of 15 people, right? 15 people were displayed in this histogram. And if we went up here, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Checks out. We've got a total of 15. This is the histogram showing the age ranges and how many people fell into those age ranges. All right, so now we're going to go down and let's do a student problem, okay? So on this one, we are going to look at which histogram correctly summarizes the data. So on this one, you don't have to make your own histogram. Tough for you guys to do at home. But basically the question is the estimated miles per gallon for selected cars are shown in the table over here. Okay. Use the data to make a frequency table with intervals, then make a histogram. So basically they already set up a intervals for you. All right. So we've got intervals already, 15 to 19. 20 to 24, 25 to 29, 30 to 34, right? So we've got that. So what you need to do is you need to tell me which histogram is the correct one. A way you could do it, you could definitely look at this data and try to make your own histogram, or you could look at the total count and see which ones are the same as the total count in this table. Okay, so I'm going to stop and let you guys try that one. All right, now that we're back, we're going to go on to example 2. So for example 2, we have a histogram showing the heights of players on a basketball team in inches, right? And I have down here height in inches. This is our frequency. So we had 2 people that are between 63 or that are basically are 63 to 66 inches, 4 people that are 67 to 70 inches, 6 people that are at 71 to 74 inches, 2 people at 75 to 78 inches, and then 1 person at 79 to 82 inches. So how many players are represented by the histogram? So again, I just go 2 plus 4 plus 6 plus 2 plus 1. So when I do that, I get a total of 15. How many players are 71 inches or taller? So at this point, we go, okay, we're only going to count the bars and we're going to be taller. So we want to go to this side. This bar starts with 71, right? 71 is here. And then we're going to go this way. So we're going to go 6 plus 2 plus 1. All right. So we get 6 plus 2 plus 1 gives us 9. And last is what percentage of students are 71 inches or taller? So we're going to take our number of players that are 71 inches or taller divided by our total number of players. So we're going to take 9 divided by 15, right? So let me go 9 divided by 15. Wow, it's a bad 5. And then that is going to be multiplied by 100 to get a percent. Okay, so when we do that, we end up with 60%. Okay, so that would be our example on how to figure out percentages, right, from our histogram based upon the question. So they wanted to know what percentage of students were 71 inches or taller. We're able to find the total number of players from the histogram, and we can also figure out how many players are 71 inches or taller by using the height of these bars. So for your problem that you're going to do now on Edpuzzle, and let me see, I'll leave that up there so you can see it. You're going to figure out how many players are represented by this histogram, how many players are 74 inches or shorter, right? So that's why I highlighted that. This one up here was taller. This one's going to be shorter. So think about that when you're doing the problem. And then it wants to know what percentage of students are 74 inches or shorter on the basketball team. So I will stop and let you guys answer those problems. Okay, and now for our last example, we're looking at example 3. We've got data representing 2 teams. So let's see. All right, so on this one, we've got team 1, points scored by a college basketball team. So these are the number, these represent the number of games. The frequency represents the number of games at which they scored points in this specific range, right? So they scored only 20 to 29 baskets in one game during the season. They had 4 games where they scored between 50 to 59 points. They had 7 games, right? The height of this is 7. So 7 games where they scored between 60 and 69 points. 9 games where they scored between 70 and 79. 6 games where they scored between 80 and 89 points. And then 3 games where they scored between 90 and 99. All right. So for this one, that's the data represented for team 1. So how many games did team 1 play? So again, all we got to do is go, okay, it's 1 plus 4, right? That's 4 plus 7 plus 9 plus 6 plus 3. So when I do that, I end up with 30 games that team played. Okay. How many games did they score 70 or more points? So on this, I got to find what interval includes 70 or more points. So it's this one right here. 70 or more means that I'm gonna go greater than 70. So all I'm gonna do is add up how many games did they have. So 9 games that they were between 70 and 79, 6 games 80 to 89, 3 games 90 to 99. So on that, if we go 9 plus 6 plus 3, we get 18 games where they scored 70 or more points. And then what percentage of games did they score 70 or more points? So again, this is when we're doing a percent, we're going to take the number. Let's grab a pen. So the number of games that they scored 70 or more points. So we found that out to be 18. Divided by our total number of games. So they played 30 total games. 18 of those games, they scored over 70 points or more. And then we're going to multiply that by 100 to make a percent. All right. And so when we do that one out, we're actually going to get 60% again, just like we did in the last one. All right. So we had 60% of their games, they scored 70 or more points. If we look at team 2, we have got the data to represent them here. These are the number of games that they, 6 games where they scored between 40 and 49 points, and so on and so on. So how many games did team 1 or did team 2 play? That should have been 2. Let's go back. So how many games did team 2 play? So again, we're going to go 6. We find the height of the column. 6 plus 9 plus 5 plus 3 plus 2 plus 1. When we do that, we find out that team 2 played a total of 26 games. How many games did they score 70 or more points? So we find where 70 is on our histogram. We go up and we see, okay, it's three games where they scored between 70 and 79, and then we just go up because we want to find 70 or greater. So 3 games at 70 to 79, 2 games at 80 to 89, and 1 game at 90 to 99. So we're going to have 3 plus 2 plus 1. So for this one, we're going to figure out our percentage. We're going to take our number of games that they scored 70 or more points, which was 6, and we're going to divide that by the total number of games they played during the season. So 26 games. right? And on that, we're going to multiply by 100 to get a percentage. All right, and so this is going to work out to be 23%. So this team, not as high scoring as the other team, right? The other team, 60% of their games, they were able to score above 70 points. This team, 23% of the times, they were scoring above 70 points. So last two questions before you try your third problem on the Edpuzzle. It's asking what team's data is skewed to the right. Remember, whenever we look for a skew, we're looking for a tail on the distribution, right? So we look for the tail. The tail points us in the direction that it's either skewed right or left. So if we look at this data over here, you can see it's like a staircase going down, but it's, this side's not so much. So this is definitely, it's got a tail on it. It's pointing to the right. So team 2's data is pointed to the right. Right. And then the next question is which team's data has an outlier, right? An outlier is going to fall outside the normal distribution of it. It'd fall outside of your first quartile. So looking at this, it's like a data point that's either very, very much larger than the distribution of your data, or one that's very much smaller than the distribution of your data. So in this case, if we look at Team 1's data, we see this one data point, this one game where, maybe there's a lot of the players who are injured or what, but they only scored 20 to 29 points in that game. So that's an outlier. That doesn't really conform with the rest of this data here. So the team that has an outlier is team number 1. Okay. So what I'm going to do is I'm going to go down to the next problem. It's very similar to this. You guys are going to answer the questions in the Edpuzzle, and then we'll move on from there to a Google form, okay? So for this problem, you're going to use Team A and Team B. Points scored by the college basketball team are listed here. So again, this one, 2 games at 40 to 49, 6 games at 50 to 59. So this will be for Team A, you're going to answer questions, and for Team B, you're going to answer questions, okay? So I'll stop, and then you guys will move on to doing a Google form.